Merry Christmas! Welcome back to Piers Rocks. I thought Christmas was as good a time as any to get started on this stack of big boy Commodore disk drives. As you can see, I've got a number of different models here, starting with the 2040 at the top, then a 3040, a 4040, an 8050 and an 8250 at the bottom. I think the 2040 was Commodore's first double 5¼ inch disk drive, so that's the one I'm going to be looking at today. Before we take a look at this on the bench, let's just take a look at the outside of the unit. As we can see, there's two different drive mechanisms at the front here. They're full height drive mechanisms, unlike the later half height mechanisms that were used in the 1541 and similar drives. In fact, Commodore went after this design to a low profile design with the two disk drives, as well as the single unit disk drives that we're more familiar with today. On the rear, we don't have a great deal. We have the IEEE 488 or Centronics connector on the back to drive the disk drive, so this allows you to plug it into a Commodore PET. You can also drive it. I've shown another couple of mechanisms you can use to drive this, either using a PC or using a Commodore 64. We've got a power cable, we've got a fuse, we've got a power switch, and just to prove its age, so I've got the UK plug that it came with here, and it's so old it doesn't have sleeving on the live and neutral pins. That was introduced later to stop you, as it was halfway plugged in, from accidentally sneaking your fingers in and getting a shock through your fingers, or like I did when I was small, put a paperclip between them as you plugged it in. That was an exciting day for me and my parents. Another thing I want to say about this 2040 is you quite often, or at least I've quite often seen online, that this is described as the US model and 3040 is described as the European model, but this one quite clearly says 240 volts and 50 hertz on the rear. So I'm guessing this was introduced for UK and other markets at the same time as the 2040 was introduced to North America, and maybe later Commodore focused the 2040 on the US market and the 3040 on the European market. We'll take a quick look inside here, although you won't be able to see in the bottom part of the disk drive at the moment. Down here we've got the two drive mechanisms. Obviously we've got a driver board for the disk drive, we've got a transformer and some big capacitors. And then up here on the lid, on the inside of the lid, you can see the main logic board plus the voltage regulators to produce the voltages needed by the logic board, and I'm guessing some of the other circuitry within here. Anyway, we'll get this on the bench with a top-down view, and we'll start by looking at this base part of the disk drive. So here we have inside the base of the 2040. Just to be clear, I've not powered this unit up. I can't remember what this unit said, or what was said about this unit when I bought it off eBay. I have a suspicion that this is the drive where the seller said that they turned it on, the lights came on, then there was a hot smell, so they turned it off very quickly. So don't know if that was just dust burning off or there's actually a problem with this disk drive. I can see some discoloration on the inside of the lid, which we'll look at when I move the disk drive around. Obviously it's fairly straightforward in here. We've got the transformer to step down the 240 volts into some voltages that the linear voltage regulators on the logic board can step down into the voltages that are required. We've got a couple of big boy capacitors here. This one says 15 volts, I'm guessing that's 23 millifarads. I'm guessing that other one is the same one. I can't see it at the moment, don't want to put my head in the shot. This is the control board for the drive units themselves. We've obviously got a ribbon cable that goes over to the logic board for logic signals. We've also got this connector, which I'm guessing is for the voltages used by the drives and this board itself. We've got another connector here. This goes to this drive unit underneath. This is drive 1, and one on this side that goes to the drive unit 0 on the other side. And then on the rear of both of the drive units there's a small control board. I can see a few capacitors, an IC and a bunch of passives on that board there. I can see the head for this unit. You can't, because this little lever doodah is in the way of. I lift it up very carefully. You can see the read-write head. That is looking pretty clean to me, although I'll give it a bit of a clean with isopropanol. I'll take this board off and I will make sure the head on this drive 1 is clean as well, and I'll also test the voltages of the transformer windings. Not quite sure what I'm expecting to see there, but make sure they're not short circuit or open circuit. And I'll also do a quick test of the of these capacitors with my multimeter. So let's get to it. So a bit of IPA under here. Yeah, there's a little bit of muck coming off, not a great deal. I shall remove this board. Right, so where's my Q-tip? Which side did I use? That side. Let's use the other side on this one. Yeah, a bit dirty. I think I'll give it another clean Q-tip. Obviously we've got a bit of dust on this driver board, not terribly excited about that. Honestly, I think the grime is coming off from the dust around the head rather than the head itself. Head looks pretty clean. Right, that should do it. So let's see if these drive mechanisms move backwards and forwards freely. Well, that one moves very freely indeed. So I might grease it later, but at the moment I don't feel the need. Doesn't have much of a direction of travel, distance of travel actually. Just want to have a quick look at the. Not familiar with how this. Oh, there we go. There was a little bit of a stuck there. Oh, I guess that's probably the middle. That's probably track 18. I'm guessing. Let's have a look at this one. Does this one move? Yeah, it moves. Doesn't sound great. There's obviously no lubrication on that, but I'll lube that later. So at this point, I'll put this board back. I think the first thing I'm going to do is I'm just going to power it on without this plugged in to the main logic board, and I will check, first of all, that things don't go pop. I'll step back while I turn it on, and then we'll see what kind of voltages we get out of this transformer. The other thing I want to do before I do that though is I want to check that this is actually earthed. Yeah, looks earthed to me. Yeah, right, chassis is earthed, transformer casing is earthed, so hopefully I'm not going to zap myself. Let's plug it in. Right, it's plugged in. I've turned the socket on. I don't know if the drive is on. Let's see if we get any voltages. 6 volts AC, 16 volts, 8 volts. I don't know which lugs of this transformer give me which pairs of windings, but I've seen 8 volts, I've seen 16 volts, and those actually look like reasonable voltages for feeding into 5 volt and 12 volt regulators. So to me the transformer looks okay. I'm actually just going to turn this switch at the back just to check that that actually turns the transformer off. See, we've got some capacitors, so there may still be some voltages here. No, so we've gone down to pretty much nothing, so it's now in the off position. So nothing went pop, so that's a good thing. And we have those big boy capacitors connected to the transformer via this cable loom, so those capacitors haven't gone pop either, which is nice to see. I think the next thing we'll do is we'll just take a quick look at the logic board before we actually connect it up and turn it on, and we'll talk a bit about the architecture of this disk drive compared to a 1541. Okay, I've turned the drive around in order to fit it on my bench and still see this side. So this disk drive, unlike the later 1541 type models actually has two CPUs in it. It has a 6502 that is the main CPU, and then there's a 6504 processor, which is a pin reduced version of the 6502 that handles communication with the drives itself, and there's a 6522 VIA chip on here as well. So we can see over here, that's the 6502 processor. That's 6th week of 1979. I was 4. This is 6504. That is 9th week of 1978. We've got 6522 here. That looks like a 6th week of 78 as well. I can't read this chip here. Try my other glasses. It looks like a MOS part 301486. Not sure what that is. We've got 6532s there, and then we've got the ROMs, ceramic ROMs here, and a space for a third ROM. I'm guessing that you can have lower capacity, a larger number of lower capacity ROMs, or a smaller number of higher capacity ROMs. I've looked inside most of my double disk drives, and I think they all have an empty ROM socket here, so that's not anything concerning. What was that chip there? That's another MPS. It's a 9 chip. Can't quite see what that says. Got some hex address here. That's F000. Maybe that's another ROM, and that's the address that this ROM is sitting at. And then we've got a whole bunch of other logic ICs. They're all dated. All of these logic chips I can see are all dated 10th week of 1979. So this is an old unit. This is 45 years old, more than 45 years old. So it'll be doing well to still be going. We've got the voltage regulators across here. Let me have a look. So we've got 340s and a 323. So these will be the two 12 volt ones. There's one 12 volt supply for each of the two drives, and then this will be the 5 volt regulator down here. Now I want to check on this board that there's no shorts between 5 volts and ground before I power it on, because otherwise something will go pop. So let's get it onto continuity mode. So that's ground. 2, 3, 4, 5, 6, 7. 110 ohms, so that'll be fine. That's not a dead short. And we don't have many capacitors on this board to have gone short circuit. They may go short circuit when I apply power to it, but I think I'm ready to apply power to it and see what happens. Fingers crossed. Okay, I'm ready to power it on. The on-off switch is turned on the disk drive. Now, because this is such an awkward thing to have sitting on my desk, I'm not going to be videoing the front of the disk drive, but I will have a quick look at the LEDs and report back once I've turned it on, assuming nothing goes pop and we don't smell a hot smell. So, let's turn it on. So, I saw all the 3 LEDs come on the front of the unit. The one in the center and the LED on each drive. Now I think they've all gone out. Can't quite tell, but yes, I'm pretty sure all 3 LEDs have gone out. So I'm not sure that's what I'd expect to see. Let's try it again. Yeah, we're seeing the same behaviour. Let's see if we've got 5 volts at the CPU. Two, 3, 4, 8. Yeah, we've got 5 volts. 5106 volts. So, might be that it's just booted and it's working, but I'm not sure why this LED, the status LED, has gone out. So let me check the service manual and we'll see if it's supposed to go out or whether it's supposed to stay on. Maybe it's just goes out if it's the drive's working properly. Interesting, I'm looking at the service manual for the 2040 at the moment, and it states that the 6532s are 6522s, but they've got 128 bytes of RAM on board as well. The 6530, which I don't think I found, is an interface chip, and the RAM inside the chip is used to control the drives. 6522 controls the stepper motors and drive motors and interfaces directly with the 6530 for the group coding, presumably the GCR coding. I've got the flash code page. We didn't get any flash codes. And you can change the device numbers on the 2040 by changing jumpers 1, 2 and 3 at the 6532 location on the logic board. So which one was the 65? That's 6532. Where are the jumpers? Oh, that's the printers. So that was the 2022 and 2023 printers. So 2040 floppy disk. It's factory set at device 8, of course. The jumper pads that have to be cut are on the 6532 location on UE 1. Okay, so you basically cut the pins that go into, or the traces that go into pins 22, 23, 20. Okay, I see them. So there, these three traces coming off the 6532. They're much smaller than the traces that you cut, or the solder pads that you can resolder on the 1541 disk drive. Now there are 3 of them because you can set this for devices 8 through 15. So that's quite exciting. I didn't realise you could have more than 4 device numbers for drives using IEEE 488. But that suggests that I can get more than 4 disk drives connected to a PET simultaneously. I think there's a restriction in the number of IEEE 488 devices you can run on a single bus at any one point in time, and I seem to remember that that is 5. Looking behind me, I have a total of 5 of these double disk drives, so perhaps one day I'll be able to run all these 5 disk drives off a single PET, and that assumes I don't get any more disk drives. I think the next step is I'm just going to have a bit of a probe around the board just to make sure everything's looking okay. It's still powered on at the moment. Just want to check that nothing looks particularly unusual, and then I think I'll plug it into my PET and see if it's actually going to communicate with the PET. I have my PET plugged in behind me. It's not turned on, and it has one of these IEEE 488 cables inserted into the rear of it, and then the other end is plugged in here to the disk drive. I've screwed it in so it doesn't accidentally fall out. Now it actually fouls this from opening all the way with this connector plugged in, so it only opens that far now, and it feels a bit like it's going to lever itself off the hinges, but I think it's okay. So first thing I'll do is I'll turn the disk drive on, and then I'll turn the PET on. And what I'm expecting to happen when I turn the PET on is this should reset. There's a reset line on the IEEE 488 bus that the PET will pull low when it's turned on. That should cause this drive, assuming it operates similarly to the 1541 related disk drives, should cause this to physically reset. If it doesn't, have a quick look at the schematic for this drive and check that the reset line from the IEEE 488 bus is actually tied to the 6502 reset line. So first of all, turn the drive on. That's done. Did the same thing this did before. Actually, what I don't think I've seen is I haven't seen the spindle motors on the drive units. I haven't heard them rotate. I haven't looked to see if they do rotate, so that's something else I will check in a few moments. And I'll turn the PET on. And I find the on-off switch. Yeah, I saw the disk drive reset. Both the drive lights came on, and the middle light came on. It happens when you turn the PET off as well. So I guess I'll do a directory listing and see if the PET can talk to the disk drive. Yeah, it can. So the drive 0 spindle motor is spinning, I didn't hear drive 1 spindle motor spinning. I don't know if it would attempt to read drive 1 if drive 0 had no disk inserted. But that's a really good sign. It suggests that the PET can talk to the disk drive, and we can try a disk. One thing I'm just trying to remember with the PET is whether there's a command to retrieve the status from the disk drive. With the DOS wedge on the Commodore 64, you can use ampersand, not ampersand, at, to do that query. Doesn't work. Let me just have a quick look at the basic manual for the PET. So I have my basic 4.0 manual. Let's have a look what commands we've got. Disk status variables DS and DS dollar. Let's try printing DS dollar. So DS, that's a read error 21. DS dollar is a read error. Looks like I should be using the directory command to read the directory of both disks. I'm not sure what catalog does. I don't think it's documented in here. No, it's not documented. Let's see if it drives both disk drives. So it's spinning the first one. It didn't spin the second one. Again, I don't know if that's normal behaviour on this drive. Let's have a quick look at DS dollar. Alright, let's get a disk in it. I'm going to use the 2031 disk in here. I don't have a 2040 demo disk, so I'll use the 2031 because that's got PET compatible programs on it. So we should remember that there are some incompatibilities between the 2040 and later disk drives like the 1541 and I think the 2031. So I think they are read compatible but not write compatible. So if you format a disk on this disk drive, you can't write it on 2031 or 1541 and vice versa. But I should be able to read the disk successfully, and the demo disk is written to the back side of this disk. Well, there's a lot of cobwebs in there. I'm actually going to clear the cobwebs out before I stick a disc in. It is pretty dusty and pretty filthy in here. And let's get rid of the worst of it. So let's insert the disc. Down you go. Alright. Moment of truth. Well, didn't read anything off that disc, and the disc is wobbling like nobody's business when the drive tries to read it. I don't know whether you can see that. Let's have a look. Yeah, you can't see it, but the whole thing is wibble wobbling all over the place when the drive spins. This is the Ghost of Christmas Future. So I'm busy editing this video and I've decided to cut out about an hour of my fumblings in incorrectly using the DOS version that's installed on the 2040. So the 2040 and I think the 3040 came with DOS 1 installed, whereas all the later disk drives, the ones that I'm familiar with, come with DOS 2 installed. And after fumbling around with the 2040 and it behaving inconsistently and weirdly and horribly confusing me for quite some time, I read the manual for the 2040 disk drive that I have on the bookshelf up here, and it explained that with DOS 1, when you install a new disk into the drive, you have to initialize that drive. So you do an open command on the control channel 15, you then send the I0 or I1 command to initialize drive 0 or drive 1. That then causes the disk drive to expect there to be a new disk in that drive. It reads the directory listing, and you have to do that every time you put a new disk in the drive. So if you swap a disk around, then you have to run the initialize command again for that particular drive unit, either 0 or 1. I didn't know this. Once I knew this, well, you'll see in a moment. Okay, I've RT'd the FM and with the 2040 and the 3040, because they run DOS1 rather than DOS2, every time you insert a different disk into the drive, you need to run the initialize command, the I command, which, if you remember, was how I managed to get this drive here, drive 0, to read the disk that it had formatted. And if you don't do that, then you risk getting error 29, disk ID mismatch, which is what I was seeing. So I will give that a go now. I've lubed drive 0 a little bit. I've not removed it from the drive case, but I've given it a bit of lube, and I've reset everything, and I will now do an initialization of drive 0. Now let's close channel 1. dir d0, and I can read the directory listing just fine. So, don't think there's anything particularly wrong with drive 0. I mean, it could use probably being removed and being given a good clean, but actually when I follow the instructions, it works. So that's a good thing. Now we'll try the same thing on drive 1. And as a reminder, I don't think I've seen any good behavior out of drive 1 to date. The last error I saw from drive 1 was read error 27, which I think was a header checksum error. Open 1, 8, 15, I1. Close 1, dir d1. What do you know? We successfully read the header in drive unit 1. So this is looking very promising. I'm now going to switch back to the 2031 disk, and in drive 0 I'll leave this formatted disk in drive 1 because I've got 2 drives. I can have 2 disks installed simultaneously, so that's pretty cool. So I'll install the 2031 demo disk in drive 0. I'll do an initialize in this drive unit, and we'll do a dir of that. Other way up. Right, let's initialize drive 0. Close channel 1. I'll scroll down to the bottom to do a dir. dir d0. Nothing. Right. So either there is a read incompatibility between this disk that was written on a, I guess it was written on the 2031 and the 2040, or there is an alignment issue between the drive I used to write this disk and this disk drive. Let's try this 2031 disk in drive 1. First I need to initialize drive 1. dir d1. Yes, I can read it in drive 1. I wonder why I can't read it in drive 0. Let's give that another go. Print channel 1 hash 1, I think it's comma, I0. Okay, VIR D1 D0. Yep. So I don't know why it didn't work the first time, but I seem to be able to do a DIR. I'm going to install the formatted disk in D1 and a reset D1. Initialize it. Print hash 1, comma, quotes, I1, quote. Directory D1. Yes, what happens if I run directory? Oh, I get both disk drives running simultaneously. And I see both directory listings on my screen in the same directory. That's pretty cool. I'm going to load one of these programs. Let's load graphic BAM view. Of course I want deload. And it loaded it from drive 0. This program provides a graphic view of the BAM disk in the 2031. Well, I've got a 2040. So I'm guessing this will use drive 0 rather than drive 1. To start, load the disk to be viewed and press the space key. Let's have a look. It seems to be working. So as I'd expect, I'm seeing a bit of used sectors around about track 18. So track 15 through to tracks 21 actually store the files. That's very normal. So the directory listing is stored in track 18, and only a couple of sectors are used in track 18, and then the files are typically stored in tracks either side of 18, at least the first files are, so that they're nice and close to track 18, so the disk drive doesn't take very long to seek to the appropriate track and load them. So yeah, I think this disk drive is working. That's pretty excellent news, given I haven't really done anything at all to it. I've reseated and contact cleaned some connectors. I've lubed drive 0. I haven't done anything to drive 1, and it's working. So I'm pretty stoked. Right, I'm going to leave the video there. I'm really stoked to have a working 2040 to add to my collection, particularly because I didn't really need to do anything to get this disk drive working. Yeah, I pulled a few connectors and cleaned them and lubricated one of the two drive mechanisms, but to be honest, I'm not sure that made any difference at all. I think the main thing was me finally reading the manual and figuring out how to use this 2040 disk drive. Since then everything seems to work pretty well. Next step for me is I'm going to try and find a 2040 demo disk image and then connect this disk drive up to my Linux PC using my XUM1541, and then I can actually write the 2040 demo disk image and I can check that out. To be honest, I don't think that will have anything that the 2031 image doesn't have. It might have the ability to select the two different drives in the test programs, but it would be nice to have the right demo disk for this disk drive. I guess after that I need to tackle some of the other double disk drives in my stack. I don't think any of those are going to be quite as easy as this one, but to be honest, with Christmas coming up for me, yes, it's here for you, but it's still a few days away for me. I've got plenty to do. The goose is very fat and needs slaughtering, ready to eat on Christmas Day, so I'm pleased to have a bit of a gimme this time around. I hope you have a really Merry Christmas and a very happy New Year. If you want to see some more of these types of videos, definitely subscribe. There'll be more of them coming in the new year. Until then, this Christmas, rock on.